Welcome everyone. In today's session, we will explore the OSI Security Architecture, one of the most important frameworks in network security. This architecture helps us to understand how different security services and mechanisms protect communication in a networked environment. It provides us a structured approach to ensure the confidentiality, integrity, authentication, access control, and non-repudiation. This model is widely used in designing secure communication protocols such as HTTPS, online banking systems, VPNs, corporate networks, and many more. Now let's discuss the need for OSI security architecture. So, as networks explained across the world, new types of attacks began to emerge, such as eavesdropping, tampering, spoofing, session hijacking, and denial of service attacks. So, organizations realized that without a universal security model, each vendor would implement security differently, creating gaps and weaknesses. So, the OSI security architecture provides a standard and consistent framework for securing communication in open, heterogeneous networks. It ensures that every layer of communication is properly protected, avoiding ad hoc, inconsistent security implementations. Now let's discuss security services. So the OSI models defines five major security services. These services describes what kind of protection the system would provide. They include confidentiality, integrity, authentication, access control, and non-repudiation. Each service addresses a specific security objective. For example, confidentiality protects data from being read by unauthorized user. Integrity ensures the data is not modified. Authentication validates identities. Access control restricts who can access resource, and non-repudiation ensures accountability. So these services are the foundation of secure communication. Now let's discuss each and every security services in detail. So let's first discuss the confidentiality. So confidentiality ensures this that information is accessible only to the authorized user. It prevents eavesdropping or unauthorized disclosure during communication. For example, when you log in into online banking, the connection is encrypted using the SSL or TLS so that the attackers cannot read your login details. Similarly, VPN tunnels protect data by encrypting traffic between your devices and the private networks. So both symmetric encryption like AES and asymmetric encryption like RSA are commonly used to achieve the confidentiality. Now let's discuss integrity. So integrity ensures that the data received is the same as the data sent. It protects against tampering, modification, or corruption of data during transmission. For example, when you are downloading software, hash values such as SHA-256 are provided to verify that the files has not been altered. Digital signatures also protect integrity by ensuring that the content has not been changed since it was signed. Various mechanisms like checksums, message authentication codes, and digital signatures help maintain data accuracy and consistency. Now let's discuss authentication. So authentication verifies the identity of users or the systems before communication begins. It ensures that the person or device on the other end is genuine. We use authentication every day by entering a password, receiving an OTP, using biometrics like fingerprint or the face recognition, validating digital signatures in HTTPS. So, authentication prevents impersonation attacks such as spoofing, where an attacker pretends to be someone else. Now, let's discuss access control. So, access control regulates who can access information and resource. It is based on policies such as minimum privilege and need to know. Common example include firewall rules, access control list, and role-based access control. For instance, in an organization, only HR staff can access employee salary records, while IT staff can access server configuration. So, access control helps prevent unauthorized internal and external access to sensitive information. The next is non-repudiation. So, non-repudiation ensures that a sender cannot deny sending a message and the receiver cannot deny receiving it. This is crucial in legal, financial, and commercial transactions. Digital signature plays an important role here. For example, when you sign in an agreement electronically or perform an online banking transaction, the system maintains locks and cryptographic signatures to ensure accountability. Blockchain technology also provides excellent non repudiation through immutable records. Now, let's discuss the various security mechanisms provided by the OSI architecture. So, security mechanisms enforce the security service we discussed earlier. They include cryptographic tools, authentication protocols, monitoring systems, and physical controls. The OSI model divides them into two categories: specific security mechanism and pervasive security mechanism. Specific mechanisms target a particular threat, while pervasive mechanisms apply across multiple layers and services. Now let's discuss the specific security mechanism in detail. So specific mechanism protect against particular security threats. For example, encipherment or encryption ensure the confidentiality. Digital signature ensures authenticity and integrity. Access control mechanisms enforce the authorization rules. Data integrity mechanisms detect unauthorized changes. Authentication exchange that verify identities through password, OTPs, and certificates. So these mechanisms work together to provide end-to-end protection. Now let's discuss pervasive security mechanism. So pervasive security mechanisms operate across the entire network system. They include trusted functionality, ensuring the system behaves reliably; security labels, classifying data for controlled access, such as confidential or public; event detection, intrusion detection system, monitoring suspicious activities; security audit trials, logs that store all user and the system actions; recovery mechanisms, methods to restore systems after failures or the cyber attacks. So these mechanisms provide continuous monitoring, accountability, and resilience. Now, how these mechanisms map into different services? So OSI security service maps to one or more security mechanisms like confidentiality mapped with encryption and traffic padding. Integrity is ensured using hashing, MACs, and the digital signatures. Authentication uses password, certificate, and challenge response protocol. Access control uses the ACL, firewalls, and RBAC. Non-repudiation uses digital signatures and time-stamped logs. So these mapping ensure that all services are supported by appropriate technical controls. Now let's discuss some real life examples of OSI security. To understand the OSI security architecture better, let's look at real life use cases. Like online banking uses encryption for confidentiality and OTP, digital certificates for the authentication. HTTPS websites maintain confidentiality and integrity by using the TLS, that is a transport layers uh, services. Organizations uses the access control to restrict sensitive data. Digital signatures secure e-contracts, invoices, and legal documents. Intrusion detection systems monitor networks for the attacks. So, the real world scenarios demonstrate how OSI security principles are used in our daily life. So, to summarize, the OSI security architecture provides a clear, standardized framework for protecting network communication. Security services define what protections are needed, and security mechanisms define how those protections are implemented. This architecture is the foundation of modern cybersecurity strategies in banking, telecom, government, cloud platforms, and enterprise IT. So, understanding the OSI security architecture is essential for anyone involved in networking, system administration, cyber security, or IT auditing. So, in the next session, I give you an overview of the security attacks that are provided in the OSI security architecture. Thank you.